Okay, Lawrence.
All right, it should be sharing again.
Perfect. All right. Well, first of all, thank you all for attending this month's OQMS monthly training session. This is part one of a two-part series. We are going to be talking about data science fundamentals and data analysis. And we're very lucky to have two SMEs in our office. So you guys know them very well, but we wanted to just give you a little bit of background just to, they have very impressive credentials. So first of all, Lawrence is gonna start off the talk, and let me just tell you, Lawrence joined the FDA in 2010 after serving 20 years in the Navy, and he began his FDA service as a quality manager in the Denver district. He continued with HAF West 4 after program alignment, and he works now as a data analyst in our office in OQMS. He's a member of ORAD's training team for about 8 years. Many of us have taken the QSM ORAD's training. If you haven't, it's a good one. Lawrence is a master's of public health from San Diego State University, and his certifications include REHS, which is the Registered Environmental Health Specialist, Registered Sanitarian, as well as the CMQOE that we're all supposed to get eventually, the Certified Manager of Quality Organizational Excellence. And he has his Lean Six Sigma black belt. So very impressive. Let me just introduce Steve right away. He's going to be giving some information. Steve Condry joined the FDA in 1994, and he began his service as a CSO investigator in the LA district. In 2002, he became an import operations CSO, and in 2012, he joined the QMS full-time. Post-program alignment, he's been the QSM for Division of the West Coast Imports from 2017 to 2019, and he joined OQMS in 2019. He has a master's degree in data science and business analytics from Bellevue University, and he's the co-chair of the FDA Data Science Council and the FDA 2022 Scientific Computing Days in September. And he's a member of the FDA Statistical Association. Steve has many certifications. His ASQ certifications include the Six Sigma Black Belt, CMQOE, Quality Auditor, Quality Engineer, ISO 9001 Lead Auditor, and lastly, the American Statistical Association Graduate Statistician. So the moral of the story is, if you have any questions about data science, fundamentals, data analysis, reporting, these are the guys, Lawrence and Steve. All right, so next slide. So just quick housekeeping, as always, please keep your phones or computers on mute. I will be monitoring the chat box. So if you have any questions or comments, throw them in the chat and we will address them at the end. There'll be a Q&A session. Tomorrow or Monday, I'll send out a training course, 60-day due date, and it'll include this PowerPoint and recording and just 8 questions. The course task, like I said, hopefully it'll be sent out in a few days. The objectives for today, and remember, this is part 1 of a part 2 series, is to understand basic principles of data science and analysis, which includes data lifecycle, analysis cycle, and types of analysis. And Lawrence will go over predictive, descriptive, and there's a few more. And the more important thing is starting to understand the available tools and when to use each one. So with that, I'll pass it over to Lawrence Sproul.
All right. Data science used to be just called data analysis, but as we increase the amount of data that's available in the world, it becomes more and more necessary to have standardized processes. And so the field of data science has been expanding. Basically, it uses scientific methods and processes to extract knowledge from data, and that data could be structured or unstructured. It's easiest to work with structured data, but sometimes there's better value in the unstructured data. It combines elements of statistics and computer science with information technology and domain-specific knowledge. Domain-specific knowledge really is a core set of understandings about what you're studying with your data science. The best data analysts really have three sets of skills. The IT skills, of course, to be able to use the computers. Data science, which is about knowing which type of analysis, which tools to use. And then the business skills is understanding what makes sense in the process that you're studying. And often it's difficult to find someone that has all of those together. So typically they'll have a team with one leader that's bringing all of those skill sets into a congealed functional team that can get us the answers that we need. And I'll turn some time to Steve. I'm not hearing anything, Steve.
Steve Condry? Why don't you just take this next slide, Lawrence?
Yeah, if you come back in, Steve, just take over and I'll pause, but I'll keep us going for now. Three key facts that are on the screen right now. As QSMs, we're in a unique position to practice data analysis, as we have not only access to large amounts of data and have a good understanding of that data in context, but we also have skills to use statistical tools to manipulate the data and give us the information that we need. So how do we use those available tools and data to analyze the processes? On the screen, we have some examples of how those tools have been put into practice that we'll be exploring in this presentation and in next month's presentation. Some of these are relatively simple, like brainstorming or using, developing fishbone diagrams, but others are more high level, such as keyword examination. Of course, the more complex things are a little bit over the horizon for most of us, but in the next few years, it will begin to play more of a role in FDA operations, especially as the agency's capabilities evolve and our skills increase.
Okay, I'm back. I had some technical difficulties on my end.
All right.
There are some possibilities for further training here. Learning how to clean data, which is how to eliminate spurious or incomplete data points before analysis. There are several techniques for doing that. Examination of unstructured versus structured data, text versus numerical data, especially once we get closer to the more advanced opportunities such as text mining. Presenting data in a usable form for multiple types of audiences. This is where we get into our descriptive statistics and our descriptive data storytelling, learning how to make these presentations not only informative, but effective for your audience. And also constructing and querying databases. I feel personally that this is a very, very neglected aspect of data science within the agency. There's a lot more that we could be doing than we really are at this point. So really the direction on this is up to you. Data science is very much a creative enterprise, and there are as many ways to look at and present data as there are people looking at the data. And this is an important point. You have to be able to customize it for your audience. What you're showing the senior leadership may not be the same thing that you are showing the average FDA employee. So you have to learn how to scope the presentation properly so that each segment of the audience gets what they need out of it without becoming overwhelmed, and gets it in a straightforward manner. And what are going to be presented here are basic tools and concepts that can be applied to the work. We're not going to go into a deep dive, at least not with this presentation. Part 2 will be a little bit more in depth, but there is so much more that can be covered in these 2 sessions. So please keep this in mind as we go forward. And with that, I'll hand it back to Lawrence.
All right. In the data lifecycle, as with the records lifecycle, there are 5 steps. Data gets created when something happens. And then we have to capture that data into some sort of storage medium, whether it's paper or a computer or whatever. And then that data gets used. As an example, if somebody does an inspection that creates data, we put it into e-inspect, and then it gets transferred into fax and ORADs. So it's stored out there. We can then use that data, if it's a violative inspection, to take compliance action. If it's non-violative, we can use it for tracking, trending, and other things. Once that data is no longer salient, we can archive it. And then if there's no future need for it, we can destroy it. Although with our modern data systems, archiving and destruction is less and less necessary, but we are getting more and more data at the same time. So there may come a time when we do need to destroy some of the old data. Since we're looking at data analysis, we need to be aware that there are also 5 stages in data analysis. We always have to start with a question. What do you want to know? What is the problem that we need to figure out? And then we need to collect the correct data to be able to answer that question. Once you have your data collection, you need to make sure that it's appropriate for the analysis you're going to need to do. Is there bad data? Are there missing data points? Are there things that need to be transformed to another type of data or another format so that we can get it to be able to do the analysis? One common problem that I've seen is a number that's stored as a text string instead of as a numerical value. When you look at it with your human eyes, you can't tell the difference, but when the computer looks at it, it sees text as text and sees numbers as numbers. So that can confound your data analysis if you have that issue. And we call that cleaning or preparing the data. Once it's all cleaned and prepared, we can do our analysis. We pick some statistical tools or some charts, and we slice and dice and present, get the numbers ready for presentation. Once we have it ready, we figure out our results and try to tell the story that the numbers give us. We can describe things about the population from the data. We can make predictions from the data. Whatever type of analysis we're going to do, we need to be able to tell that story in a way that the audience understands and takes the appropriate message so that they can make appropriate decisions and prompt us with new questions. Quick question, why do we need to clean and prepare the data? If you could just shout out or chat your answer. Chat's probably better.
Yep, if anybody, you can just put A, B, C, or D into the chat.
I'll wait a few seconds and then move to the answer.
Yeah, all right, so I got a couple, I got 3, 4.
Yeah, it looks like everybody's saying D, which is the correct answer. We often in our data collection have numbers or entries that are not valid or left blank. Sometimes outliers can be a problem for our data. We don't always want to delete or remove outliers. Sometimes we'll need to use some sort of transformation to handle them in some other way. Now here there are 4 main types of analyses. The easiest ones are descriptive. That's we've all done some basic descriptive analysis. We take some data, something happened, and we take a retrospective look at a single sample of the data. We can also take a next step where we can look at factors in the data, some variable, and see how it changes the output of our analysis, and we can use that to make predictions. And so looking forward, we have prospective analysis and prescriptive, and looking backwards, we have retrospective and diagnostic. The diagnostic and prescriptive ones take multiple samples or groups within the data so that you can compare two or more things and help to find out which one of them is best or worst, so that you can make a decision about where to go forward from there. In quality management, we talk a lot about trending or trend analysis. It's not really a separate type of analysis. It's basically using each of these types of analyses in order to look at a set of data for a process over a period of time in order to find, describe, predict, or change the patterns that we find. And the patterns are the trend. So for descriptive analysis, we're typically either going to be doing aggregation or statistics. Aggregation is really just counting something. You may segregate it into groups and count within the groups. And then that data can be displayed in charts, graphs, or tables. For statistics, it takes a little bit more effort. You actually are doing various calculations on the data. Most of them can be done automatically through the software that we have, which makes it a lot easier. When I first started learning this, I had to do it by hand, which was not fun. It took a lot of time. So those are the typical statistics that we look at are average, standard deviation, normality, modality. People have a tendency, though, to forget things like normality and modality tests because they take a little extra work. But they can make a big difference when you move towards doing the more advanced analyses. Predictive analysis starts to looking into why things are happening and what is likely to change in the future. You can see that in the picture, we have this bell chart. In statistics, we're focusing in on the main core of what's happening. With predictive analysis, we start looking at the edges. Why is something out of the normal distribution? Why are we getting these outliers? What's the impact? What factors are impacting it? So we can use models and decision-making. We can use these for modeling and decision-making, planning, and other types of predictive activities. The tools and techniques that we use are typically things like correlation and regression, which are similar, but there are significant differences between the two. We also use time series models and simulations to look at what might happen depending on the input that we get in our system. Diagnostic analysis is really about why did something happen? So we use a variety of hypothesis tests to figure that out. We can also do various correlation and regression type studies. But our focus is more looking for causation rather than just correlation. And if we can have a repeatability for our results, it increases our strength and confidence in them. Typically, we'll use a test like the t-test, the z-test, and there are other comparative statistics that allow us to compare two groups or two populations against each other. The most important factor about these is you have to have a hypothesis or your question, but you state the question as a null hypothesis. So, which basically says there's no difference between condition A and condition B, as you might see on this chart. And what we find, we did, the chart shows two lines, two groups, and there's appears to be a significant difference, although the lines are nearly parallel. There's a significant difference between the two groups of data based on that condition. Prescriptive analysis is probably the most advanced form that we're going to be talking about. It's really about what's the best way to move forward and improve the outcomes for our process. And the techniques can be fairly complex. We'll talk about response surface methods, factorial experience, experiments, regression analysis, forecasting, multivariate statistics, and predictive modeling. Many of those are beyond the scope of this course, but they're also beyond what our needs are typically going to be as quality managers. But there are projects where they will be useful to us.
Okay, here's another knowledge check for us all. Which of the following is true of trending analysis? A, compares multiple points of data from different times. B, attempts to find patterns. C, is a requirement for management review per ISO 9001:2015. Or D, all of the above. Please go ahead and put your answers in the chat.
Looks like everyone's saying D.
And in fact, the answer is D. It is all of the above. Trending analysis is at the heart of modern quality assurance. And as a matter of fact, if we look at the ISO standard, it requires comparing points of data over multiple periods of time to find trends in customer satisfaction and feedback, the extent to which quality objectives have been met, process performance and conformity of products and services, nonconformities and corrective actions, monitoring and measurement results, audit results, and the performance of external providers. We also addressed this in section 4.3 of Staff Manual Guide 2020, which is more or less harmonized with the ISO standard and also with ISO 17025 for the labs. And we have a number of available applications for data science here in the agency. We have three large categories going from simple to more complex. At the very basic, we have Microsoft Excel with or without the QI macros plugin. QI macros is very, very handy for spreadsheets and numerical data. You can just go ahead, select your data, select the type of analysis you want to run, and it'll pull up the chart right away. And you don't have to do a lot of heavy-duty hand calculations to do it. And it comes up with a simple and elegant presentation. Has all the different major control charts listed, Pareto charts, frequency breakdowns, and so forth. OQMS controls the license for that. So if you don't already have QI macros, I would encourage you to get it as soon as possible. Microsoft Access is more specifically oriented toward databases and requires a bit more training and is a bit more advanced than what we need, but also more on point for databases, because you can have primary keys and secondary keys, and you can sort from a large amount of data just by specifying which fields you want to pull up. These are the current workhorses that we have in OQMS. Coming in just ahead of that are ORADs and JReports. ORADs is our main data repository for the field. It has all of the information that's generated from field activities in searchable format. Again, this is also usable as a database type function. So if you really want to invest some time learn something about data management or database management, that would help you all out tremendously. JReports in QMIS is also very, very helpful, especially now that we have the quality factor checklists incorporated into QMIS. And if you want to go into the deep dive, go and learn R or Python programming languages. They're both open source. They're both available for FDA computers. And there are training courses available in the HHS learning management system. And I'll be covering that in the final slide in the presentation. So these are some tools that are handy, that are available to everybody in the agency. And I would encourage you to get your arms around them as soon as possible, especially with QI macros.
All right. Nowadays, you pretty much have to have some sort of software to do our analysis. And typically, we need some idea of how to pick which software to use. One of the key things that you need to look at, do you have it already and do you know how to use it? If you don't have it, is it available on the approved software list, the MAT list? Can it really do what you need it to do? Do you know? And can it present the visualizations that you need? Looking at more detail about what's available to us, the highlighted ones were already covered quite a bit. Excel, ORADs, and JReports, those are going to be our main tools that we use. Each of them can do some level of analyses, but some of the analyses are more easily done by downloading data from ORADs or JReports and then running Excel or QI macros to do the analyses. We do have Tableau, and that's used in the dashboards that the programs have set up in SharePoint. With Office 360 and SharePoint, the newest one that we have, the Power Apps platform is available, and that can be built through SharePoint or Teams. They're supposed to be pretty much interchangeable, but the way they're configured in ORA and FDA, they're very separate, and bringing data from one to the other is particularly challenging, if not impossible for most people. But they are a great way to do a data collection and then analyze that data. You could build surveys or something like the vaccine self-certification application was built in Power Apps. Power BI is kind of a cross between Power Apps and ORADs. It's available and can do some pretty powerful things if you can get data into it. But the more advanced functions require an expensive license, and the IT folks are very stingy about giving access to those licenses, partly because it can't be just your license. You can do great things if you have a license, but you can't share it with anybody unless they also have the expensive license. Over on the right, we have Minitab, which is great, but it's also expensive. And most of the features that you can get in Minitab are available in QI macros. So the cost benefit is not there for most people. And then, as was mentioned, R and Python. And for R, there's actually a graphical user interface program called RStudio that can make it a little bit easier to use R. That in some ways resembles the functions of QI macros or Minitab, but has a lot more capability and can actually, with R and Python, you can actually get into AI and the more fancy analyses. But you want to start right where you're at with Excel, JReports, and ORADs to get things done. Of course, we want to do the most useful analyses where we're going to get the best bang for the buck. The keys are to remember that it has to answer a question. What's the business need? What do we need to know in order to improve our work process? We need to look at and show relationships within the data in order to describe what's going on, to compare two or more groups, predict what's coming out of our process, or determine the best action to take in some business case. If you're paying attention, you'll see that those fairly well align with the 4 types of analyses. So a little while back, I was involved in a project that's built around the FMD 145 process. For those who don't know, FMD 145 is a process that was developed to ensure that we are providing a copy of the inspection report to the inspected firm in a timely manner. There's a Federal Register notice that requires it, and the FMD Field Management Directive number 145 was established for that process. And so we've been, over the past 10 years, we've had a number of projects that looked at improving that. This particular project looked at the quality factor checklist for those FMD 145s in our most recent electronic process. In this data, we have dates, we have categories, labels, we have yes and no values. So we're able to take that data, and we can do lots of different types of analyses. We can look at changes over time. We can look at rates over time. We can look at raw counts of the data. We can look at control charts for it. This particular data set was probably too small for a control chart, but in the future, we could, with a larger data set, we could probably do control charts on it. So we looked at cleaning up our data. We found some issues as we were looking at it. Some of the questions had no value entered. There wasn't selected yes or no or NA, it was just blank. So that affects our ability to do analyses on that data. On the right, you can see that there are also missing dates and missing counts of days between two dates. For the dates, we know that they're stored in another data system called CMS, the Compliance Management System. So we're able to go out and look up what those dates are and fill them into our data set. Fortunately, there was only a handful of blank dates, so it's not that hard to go in and correct. And then the days to send would be able to be calculated from that. For the missing data in the yes/no questions, we decided our best option was to count how many were blank. And we did see that there's a trend. Certain ones over here on the right had a lot of blanks. Well, it turns out that question 14, the answer to question 13 determined whether they needed to go to question 14 and 15 and 16. And so technically they should have marked them NA, but they chose to leave them blank. So it's not really a big issue. We were able to then focus on the no answers, which in the way we do our quality factor checklist, a no answer indicates a defect. So we took that data and put it into a Pareto chart. The first one on the left has all of the questions in it and sorted by order of frequency. The labels on these charts are different, but they're showing the same data. The chart on the right is what we end up presenting for our results. And you can see that the defects, the labels make more sense for presentation on the right. On the left, it was just defaults. We looked up what question 19 was, and it said, was this QFC reviewed with the supervisor? Well, that's not a particularly valuable no answer, because sometimes no is not a significant defect. In fact, it's not a defect if there's nothing that they need to report. So we discarded that question, and as you'll see on the right, we start with question 11 as the most significant, and question 5 is the next. Just real quick, question 5 asks about email address captured in the EIR. And that's a pretty significant issue, because without the email, we can't send them the dispatch by email. We have to send it by paper through the mail. But one thing that we knew, we had to know the process. And there was a change in the process that occurred during the time that this data was collected. So some of the inspections were completed before the email was required to be captured, and some were completed after. So for the ones that were completed before, it's not truly a defect. And so we ignored that question. But question 11 is significant because it says they didn't meet the established time frame, which is 45 days. And of course, the whole purpose of the FMD 145 process is to meet timeframes. So we focused in on that and did some further analysis. We looked at the timeliness data by week of the year through this time period, and we saw some interesting patterns show up in this data. Just to quickly summarize, we saw that there were peaks associated with holidays. I knew that the PSSs who do this work had gone to an OREDS training class relative to one of these. And we had, of course, effects on the number of inspections completed and other things due to COVID-19. And if you look closely at the data, you can make some guesses about when those things may have occurred. There were additional issues that we identified related to the timeframes, things like whether it was a state inspection or not. There were differences that came up. So we saw this, and we wanted to think about things that could make a difference in those timeframes. So we brainstormed out a fishbone diagram to identify various factors that would feed into pushing things to be late. And many of these were in fact the case. We did have new personnel. We did have departed personnel. We did have people trying to do this before they knew what they were doing. And we did have configuration issues with the computer system. So many of these things end up being identified as potential causes and actual causes, which allowed us to then focus in more detail to try and figure them out. Another analysis that we did is a fairly complex one. This is called a value stream map or value stream analysis. I'm sorry that the screen is so cluttered and busy, but this is really less than half of the actual full diagram that we developed for this process. So a value stream map is a lean tool from lean manufacturing or Lean Six Sigma that's used to analyze, design, and manage the flow of materials or information that's required to bring a product to the customer. So from when an inspection is completed until that email is sent to the firm, this is all of the steps that take place and how long it takes to do each and how long you're waiting in between each. And it shows branching within that. At the top, for example, we found that in our study, 99% of these EIRs did not require redaction. So the numbers in this section for the time it takes to do the process are large, but they have a small net effect on the average time overall. And in the rework, there's a 5% rework. It also has a small amount of impact on the overall average time frame. So there are lots of pieces of information that we can gain using these. They do take a lot of time and effort to build. You have to physically watch the process with a stopwatch and get measures for the time. Some of these we were able to pull estimates like the waiting time out of ORADs, but in some cases you're not able to do that. And but those of you who want to work on something like this, Steve and I can help you to get these types of analyses done if you need them. True or false? Value stream mapping is an extremely complicated method and should only be attempted to be used by the most advanced data scientists. Go ahead and type in your answer, true or false, into the chat. It looks like most of you are getting it right. It is very complex, but it's not beyond your skill set. Well, it may be on the edge of your skill set right now, but with a little coaching, you can do it. And we are here to help and make sure so that if you need this level of detail in your analysis, we can make it happen. And there are plenty of opportunities in our processes in the divisions where there could be a lot of value gained from it. Quick summary. Data science and data analysis uses scientific methods to gain insights about our product, process, or other data. A good analysis requires business knowledge, IT skills, and data science skills. People tend to forget that business knowledge piece. You have to know what you're looking at to get a better sense of what tools and whether the answer that this tools give you makes sense. As QSMs, we have access to large data sets. We have the skill sets that enable us to do at least basic analyses. And then for the data lifecycle, there are 5 steps. We create, store, use, archive, and destroy the data. Although archiving and destroying is less necessary because storage is getting cheaper and cheaper. When we do an analysis, we have to go through all 5 stages. We ask a question, we gather the data that's necessary to answer the question, we prepare it, analyze it, and then we present the results to somebody who can use it. There are many software applications and tools available for analyses. We do need to choose carefully, make sure we have the right tool to get the answers that we need. If we choose the wrong tool, we'll get the wrong answer. And the analysis types are divided into 4. We have descriptive analysis, which is what's happening, predictive analysis, what is likely to happen, diagnostic analysis, why is it happening, and prescriptive analysis, which conditions can we change to make things happen better.
Coming up in part 2, which will be on March 10th, we will have some additional topics in data science, which will include the basic quality tools for data analysis, some common do's and don'ts, and how to generate effective descriptive statistical presentations. If there is a tool that you would like to get additional training on, please add suggestions into the chat. Part 2, we're going to cover the original 7 quality tools related to data analysis, box plots, control charts, frequency distributions, Pareto, and how to effectively present the data, which is a piece that's often overlooked in a lot of this training. And for some additional resources, you can go to the HHS Learning Portal. I've listed some introductory topics that you can go ahead and type into the search window there, and it'll pull up the courses. All of these courses are free. All of these courses are online. You can go ahead, portion off some time to take them, and get yourself some grounding in data science. For those of you who have a deeper interest, you can go ahead and connect with the FDA Data Science Council. I've linked their SharePoint site here on the slide deck. And outside FDA, there is the Open Data Science website, which has a lot of free or publicly available information that you can look at as well. So with that, I'll turn it back over to Kathy to answer any questions you may have.
Right. Well, first of all, thank you, Lawrence and Steve. I think that was just really good information, a refresher for some, also just a different way to look at the data and think about what you can do with the data that you have or what your management might need. At this time, I don't have any questions in the chat. So you either can raise your hand and I can call on you, or you can put it in the chat. So let's just give a few moments for that. One person, let me just say though, did ask about the QI macros. If that's something that you're interested in, OQMS holds those licenses. And so just contact somebody in OQMS, probably Lisa Lopez or Mo, and we can get you set up with that. Marcy, I think you have a question.
I do. So QMIS is a giant database, and we are thanks to the new reports, we're able to do more. I'm running into a problem that we had with the older version of QMIS, which is there are a lot of reports and I am having trouble telling which ones do what. So for example, I'm trying to take preferably a report that's already been made that tells me if anyone in my division has training that hasn't been completed yet. And I go into the public folders and there are a lot of reports in there, and trying to figure out which one is the one that has been blessed, that has been looked at by the OQMS team and is the best one to use is, it's getting kind of painful because there are a lot in there.
Yeah. Marcy, one of the things that we're trying to do on that is create a report that has a list and describes which reports are best for which. And so there should be one for audits. I know the audits one is in. I don't know if the others have been developed yet, but for training and for documents and for each of the core processes. But the other thing that we're doing is we're giving the best reports a new name. So in audits, they all start with A and then a number. It's A01, A02. And each of those are the best ones for audits. For the business process, like UFCs and forms and things, that's going to be all starting with a B. Training courses all start with C, and documents all start with D. So it'll be a letter and then a number. Some of them throw a 0 placeholder for 1 through 9. Some of them don't. But if you just search by that letter and number, it'll give you a great starting place for the best reports to begin with.
Correct.
That actually brings up a very important point about metadata,
Right.
which is the data that you use to describe the data itself. A good example being the QMIS info card is basically the library card for a document. Well, with these reports, we're trying to get the names to be more descriptive so people know what they actually do when they're looking at them. And that's why we're trying to standardize the naming conventions. That's why we're trying to make the names a little bit more descriptive. So it is easier for you guys when you're going to look for a report to know exactly what a report is and what it does. This is an ongoing process, and it's expected to continue even through the release of the upcoming Classic 20 version of QMIS, which hopefully will help expedite matters as well.
Then maybe a better question would be, you talked about cleaning data. How about checking data to make sure that the analysis that you're doing is giving you the correct stuff? Do you have any tips and tricks on how to make sure that your analysis is actually providing an answer as opposed to a not answer?
Yeah, there are a variety of levels of validation and types of validation it can use. There is a full-on science called measurement system analysis or measurement system validation. But at the basic level, you can take and look at the output that you get and go into the original source and pull up some examples and compare the data that you're getting in your report with the source data. And that helps you to verify that you're getting the right answers in the data set. And then you can look at your data analyses and try comparing it a couple of ways. In one case, I had an ORADS report that was figuring out the average of a particular data field. And depending on how I created that formula, it would give me different answers. I was able to get 3 different answers just by using an average of a particular number. And the average ended up being different because of the way ORADS thought of the data as being either a number or a label. So there's no easy way. One of the things that you can do also is you do your preliminary analysis and show it to somebody who's an expert on the process. And does that make sense? So if you're counting inspections, the director of investigations and the supervisors, they all have some idea how many inspections are going to be done during that time period. So they can be a quick way to bounce that information off of somebody.
And this is where graphing the data comes in handy as well, because if you see an extreme outlier, that could just be a spurious data point, or it might be a point where the process went really haywire. And either way, you want to dig into it and find out. So if you see an anomaly like that, don't immediately discard it, dig into it and find out more. It may actually be telling you something about the process.
Right. Yeah. In some of our data, for example, the people are entering 2-digit dates instead of 4-digit dates. And so that can create outliers. And so then you can, by looking at the original data source and how it's presented, that can tell you a lot how to handle it.
Okay, thanks, guys. Can you see my master control screen?
Yes.
Okay, so Marcy, under each module, under public reports, Lana created a summary. It should be the very first report. And if you click it, it'll show the reports that we created. Let's see here. Yep. And here's my C1 through C5. Here's the name of the report, the description, and then what columns it has. So there's one for audits, business process, training, and docs. Now, these are the ones that, our groups created, probably with the help of, some of the J reports folks, but you're welcome to use any of them, but these are the ones that we really like, and then we'll continue to add to it. So, and that should be at the front, when you go into the module, this is the default, and look at all these reports I have, right? So if I go to public, that's at the front, and then here's all of mine, C1, C2, and it could have been T, right? But here's what happened. Kevin started it with A, and oh, that works, right? A for audits. And then Melba's like, oh yeah, I'll take B. Oh, awesome. Debbie's like, hey, I'll take D. Great. And then I didn't want to be the oddball. So that's why I took C. And then it's just easy, A, B, C, D. All right, let's check. I don't see any more questions in the chat. Any other questions from the audience? Yes, James, C for course. I also say C for Kathy or competence or curriculum. All right, I think that's all we have. Like I said, I'll be putting the course together with just a little exam. It'll go out either tomorrow or Monday. And I thank you all for your attention and your participation, and look forward to everybody coming back for March or part 2. So with that, I'll close up and have a good day, everybody.